So today we'll be setting up the room boundaries and adding in random enemies, correct?
Pretty much, yeah.
Alright, that sounds good.
That's up and
I'll
running. So,
gotcha.
as of the end of our last meeting, this is what we had. We had a player. They are able to walk around. They are able to pick up coins. And they can die. Yay! So, the next thing that we have to do, we've got an enemy that's stationary. But one thing that I think about when I'm thinking of Zelda is like, in addition to like, you've got enemies that spawn in when you enter the room and they delete themselves when you leave. So, I'm just going to copy my prefab over and then I'm going to discuss how it works instead of remaking it entirely because um, it's more efficient to do it this way. So, oh, we have a second person. Howdy.
Hey,
Hello? Howdy.
yeah,
Oh,
Have you watched the recording of the previous meeting?
I have not.
Okay. Um, the series does kind of like build off of each other. So we have moved on a little bit since the last time you attended.
Oh,
Um,
I'm just honestly just here to be with y'all.
that's fine. Just so you know, I am currently recording, and that will be going on our
Oh,
YouTube channel.
okay.
I can edit that bit out, I
No,
suppose.
it's so big.
Okay.
I don't mind.
So as of last time, we have an enemy that, a stationary enemy that's the spike thing, and the player can respawn. So the next thing that we're gonna do, I have made this prefab called an enemy room, and yeah, I'll make it be this one. I believe it's 8.5 and 0. Okay. The enemy room prefab consists of a empty game object that has 4 of these doors. Each one covers a door hole because my game is very grid based. And it doesn't exactly cover the thing, just kind of make it more obvious that, like, yeah, that's a door instead of, I don't know. And another thing is that it has this other empty game object called enemies. Doors are untagged and have box colliders, and enemies are not tagged, but enemy room is tagged and it has 4 box colliders at the edges. Yay. So that's basically what it looks like. And now that I've gone over like what it physically is, not I should probably go over what I'm trying to accomplish with it. So the idea is when a player enters a room, by default these doors are going to be off. Um, if you guys are familiar with the Zelda franchise, you might know that like sometimes, ooh, I enter a room and the door's locked behind me and the enemies spawn in, and then I gotta kill all the enemies, and then when the enemies all die, then I can leave. Um, Similar concept here, except I still haven't added in the functionality of being able to kill enemies because this game development, I've tried to like block it off into different sections, and then the idea is that you know, each week we learn a different thing, we add in a different concept. But this is a little bit different than platformers where I can't exactly do everything separate. So we'll go over how to open this room back up later. Enemy rooms. It has a missing script, which means I need to copy over this script. Again, when you are copying prefabs from one thing to another, make sure that it has all the right scripts, otherwise, it won't work. Okay, so my enemy room script. Here are the different prefabs that it takes. One of them is a type of enemy. I wanted to take in this enemy. So this enemy, I'm not sure if I had him in the last game. He is the same thing as those spikes, but I also went through and I gave him capsule feet because I thought that's how you can distinguish between spikes and this guy that'll follow you. And he has the enemy script, so we're going to add the enemy script to him. Yeah. And this enemy script, he is living. With the way that my enemy script goes, I believe I went over this in the previous meeting. It starts off and it selects a random speed. I kind of promised I was going to go over how to randomize values. So we're going to use the start function. Start runs once at the very first time that this game object, like for the first frame that this object exists. The idea is that it initializes anything. So I'm trying to think of a good comparison for this. It's gonna be used to like I guess it's like a constructor where it goes through and it sets up what all your variables should be. Because you can set up like primitive stuff and some stuff, but you can't call functions in this area. So if you need to call a function in order to set up a variable, you use the start method. So the speed, we have default values for the speed, and you can change that. But when the game starts, the first frame that this enemy exists, we're going to multiply its speed vector by a new vector. And this new vector, random.range. So people who are familiar with Java are probably familiar with math.random. Well, instead of it being a math class that you call the random function for, it's the random class you call the range function on. And it's random, and you select a range. You put the minimum value and the maximum value. In this case, I'm choosing 75% and 125%. And it's multiplying each of those two by a different value. So you might have some enemies that are really good at running up and down, but aren't good at running left and right. If you want to just have like fast enemies and slow enemies, obviously you can do that. But this is how the random function works in Unity. I feel like it's important to include it at least once, if not multiple times. And yeah, it sets the speed to something different every single time that this enemy is created. That way, I don't know, you can distinguish between different enemies, and it feels a little bit interesting. Like, oh no, that one's faster. Obviously, if you want something more dramatic, you could make it like 0.75 to 300%. But for the most part, it just functions like the player, except its target position is always where the player is. And it has this public function, be gone. This allows... It's basically just the destroy thing. This is, I suppose, what you could call a destructor, which is something more of it's more of a C thing than a Java thing. This is just a function that you can call to destroy the enemy, and then there's get hurt that will return how much damage it should do if you bump into it. So that's the enemy. I believe I already went over that in the last meeting, so I apologize if I did. But yeah, now you can see that if I hit play, this guy follows, and he's kind of slow, so we can make his default values a little bit faster. he's a scary enemy and he's kind of fast. And if we pause it, then we don't have to worry about the player dying. And if we select this particular enemy, we can see what his speed is. Huh. Oh, because he already existed when the game started? I wonder if it didn't call the start function. Or whether it just used his default values. I'm not sure. But now we're going to get into the enemy room. So I have the enemy room that I previously described, and in the script for that, it accepts an enemy object, and it accepts a transform. So when you pass in a prefab, you pass in the transform for the prefab. When you pass in a game object, pass in a game object. The difference is this is a transform, this is a game object. Is that distinguished enough?
Yeah.
So this guy down here is a prefab asset, and its official type is a transform. I'm just going to make sure that the enemy prefab has the right script on it, so that way when we make copies of him, he will actually work. And these guys are going to be fast. Okay. Can we clear? Lovely. Okay, so the enemy room script accepts an enemy. It also accepts a number of enemies. By default, it'll summon one enemy. You could make it summon 75. It doesn't really matter. And then it also accepts a boolean, which is, should I lock the doors? The idea of this is that you could just make tons of these objects, and it'll either deactivate or activate the doors. And it can like open the doors multiple times and lock the doors multiple times. And then it has a private game object, enemies, and a boolean has entered. Enemies is the child of the game object. We don't need that anymore because we stole the assets from it. So in the enemy room, it's looking for this thing. So that way we just have like a nice place to hold all of our enemies. And you can see at start, it's going to set that game object equal to a game object.transform.find. So what find does is it's going to look through a list of all the children. So in this case, it's going to take the transform of the enemy room, and it's going to go through all of its children until it finds one called enemies. Enemies. And then it'll take that game object and store it in the enemies variable. And that's just so that way we have a nice place to hold stuff. Don't need that function, it's redundant. Alright, so void on trigger exit. So I was using on trigger enter. There are a couple of different variations on that, and I use on trigger enter most of the time because you want to know the exact frame when you first hit the thing. Sometimes you want to know the frame when we stop touching an item. That's what on trigger exit does. The last frame where you're in contact with this thing, that's when it'll activate. So, like if you're touching an ice block, and at the end of touching the ice, you want to stop being slippery, you'd use this. So, if we shouldn't lock the doors, or if we have not currently locked the doors and we have entered. So if the person is in the room and they weren't supposed to lock the doors, then we're going to delete the children of the room. This is basically clearing the room so that way when you leave and the doors aren't locked, you don't have to worry about the people following you into the next room because they're going to delete itself. So this is going to use a for each loop. You give it a type, you give it an identifier, and then you say in. I believe in Java, for each loops use a colon. Here we use just the keyword in. So type, identifier, in, where to look. So it's going to look through the enemy's object and it's going to get every child of that. And then for every child, we're going to call the begone function. I'm just doing that to show you that you can call functions of children, and that's how you like cycle through every child. Yeah. And then it's gonna reset the has entered. So has entered is a variable that triggers when you enter the room. And then I set it false when you leave. I could probably name that a little bit better, but it makes sense for me. And then I have this other function which is called do stuff. Try to be more clear when you're naming functions because do stuff is really vague. Don't be like me. Actually put effort into writing your scripts. So when you first enter the room, maybe I should rephrase a little bit. The enemy room has these. Instead of it having one collider, it has multiple colliders, and they all count as the same object. And when you enter the room, can I also show? I'm gonna move this down, and I'm gonna show you the enemy room and the main cameras. What I want to have happen is here's the collider for changing where the camera is, and here's the collider for have you entered the room. The reason why they're not right on top of each other is because I don't want it to be that when you immediately enter the room, like if I enter the room, the player's going to be here. And I don't want it to immediately lock the doors while the player is still on that thing. Because then the player will get shot out in a random direction. So instead of getting shot out in a random direction, we use on trigger exit so that way the player is like moving into the room, and when you exit this collider here, then it'll lock the doors. If we use enter, then it'll lock the doors as soon as you touch this, and that's frustrating. So when you enter the room, it sets that boolean equal to true, and then if we're supposed to lock the doors, it goes through each child and it sets them all active. I will note, this also is activating this is going through the enemy room and activating all the children. This includes the enemies. It's a good thing that we want it to be active. But if we were to loop through and deactivate everything, that would include the enemy's game object. So be careful when you're trying to use the nice for each loop. So it goes through, and if we're supposed to lock the doors, it locks all the doors by setting the doors active. Then, for every enemy, and here's the fun bit, we're going to make a new vector 3. Why a vector 3? Well, simple. We're still in a 3D space, even though we're in Unity 2D, and you can change what level players are on, and like you still have. I've gone over this before. We're still in 3D space, so it has to be vector 3. When you're first creating an object, regardless of whether you're in 2D or 3D Unity. And then we're going to make this new vector 3. I'm going to set the x and the y randomly. I go from -7 to +7. So that is from about here to here. So it chooses a random spot within there. Sometimes this is directly on the player. If you want to get fancy with it, you can make it so that way it'll always spawn the player or spawn enemies on the other half of the room. Bonus points to whoever figures out how to do that. I'm just trying to keep things simple. It picks a random spot in the room that isn't immediately on a wall, in order to keep things simple. And then we're going to use the instantiate function. Woo! If you've taken a programming class, you've probably heard instantiate. It just means it's a fancy word for make. So we're going to instantiate a new enemy object, and enemy here is that transform that we got at the beginning. So you pass in the transform of what you're trying to make. You pass in where it's trying to go. You pass in a quaternion. Quaternion? I believe that's a math thing that has to do with angles. I'm using quaternion identity, which basically means don't be rotated. I believe that we have a math person in the call who might understand what those are a little bit better.
Wait, what? A quaternion?
Yeah. Something rotation.
Quaternions are like, they're like, okay. It's like a number system that like extends complex numbers. It's like, so I can explain it to you some way, but it's basically a 4D like coordinate table.
That sounds really complicated. And
it's not that bad.
Not to put you on the spot there, but what I'm trying to say is it's some really complicated math, and if you want to get into complicated math, that's something that exists in Unity is these things. I don't really know how they work, but you have to put in one. And I found out that you could just plug in identity and not have to do any math, which is nice for me. But if you're trying to do fancier stuff with rotation, I believe you're going to need to know how that works. So you pass in a place for it to be. And then you also can pass in a place to hold it. So in whole, it passes in the prefab object that we're passing in, a location for it to be. I'm using GameObject.transform.position, so that's the location of the enemy room, and then we're adding in that random vector. So it'll either like subtract 7 and move it over to the left, or add 7 and move it over to the right. And then it'll also add stuff to move it up and down, but it'll be relative to where the enemy room is, so that way it doesn't spawn outside of the enemy room. And then it does the fancy rotation thing that's advanced math. And then I want to store it in the enemies.transform. That way it'll become a child of the enemies. So it'll get stored in this file, so that way I can go through and easily delete them all when you leave the room. Did I explain that clearly enough?
Yeah.
Because this is what took me about like 2.5 hours to figure out, which isn't a long time, but it feels like a long time when you've got other stuff that you're supposed to be doing. Well, I suppose I'm in charge of these meetings, so it was something I was supposed to be doing. But we got the enemy room, and I can minimize those colliders. Let's have it spawn in 3 enemies. And I'm going to delete this guy so that we don't get confused. We need to pass in the enemy prefab. And the reason why I make it a prefab is so that way if I decide that it's going to spawn in the big boss, not big boss, but like a different kind of enemy in this room, then you can have it pass in different kinds of enemies. You can make it randomize what enemies you spawn in if you have in like multiple prefabs that it passes in and selects a random one of them. You can make this advanced if you want to. Please make this more advanced than my game. My game is like bare minimum. So I walk into the room. Ooh, it spawned in all these enemies and they're really fast and they killed me. I'm gonna make them slower because that was too fast. So we're gonna make them way slower. I'll put them back to what they were, which was 0.2, just so that way I have a chance to escape. But what's gonna happen is we're gonna enter the room and they spawn in, and they chose random positions. That was a different position than they were last time. And I'm gonna leave the room. I'm gonna pause real quick, which it still is preserving where everything was. And you can see it deleted them. Yay! So I can play the game. They spawn in and I leave. They spawn in and I leave and I spawn in. They choose random positions. I suppose it kind of feels like Weeping Angels because I leave and they spawn in at different places each time. Ooh, they move around real fast when I'm not on the. Ooh. Apparently, there's a known glitch. What? Okay. I
Do they
believe
just
what
all disappear when you hit? If
they
you move
all.
into the edge, the edge of the room, they should all disappear. Maybe.
So maybe I should clarify a little bit better. The enemy room. Can I show you the edges? I want to show you the edges. Lovely. So what happens is every time that you exit,
Oh.
when you stop touching that, that's when it deletes the enemies. And if you get close enough to that edge that you can bump into it, but it's not close enough that you trigger the camera movement, you can technically enter the room and it won't delete. You can get it to delete all the enemies without you leaving the room. Um, there are ways to get around that. It is advanced stuff that requires more effort than I, you know, not that I don't
Yeah.
put effort into these, but what I have works. It's just that there are exploits.
Hmm.
You could technically make a game that relies on figuring out exploits.
That would actually be a very interesting concept. I might think about that.
Yeah. Free game idea from me. Make a game that
Wow, thanks, Dora.
entirely is based around the exploits of my lazy coding.
How bad can you break my game?
um, but yeah, that's how my enemy room works. And I suppose I can show you how locking the doors works. Just for funsies, I'll lock myself in a room with enemies. Ooh, I'm locked in a room with enemies. It's so scary. Can't get out. No. No, I'm gonna die. Ooh, I didn't respawn.
Is it?
Oh, that's because in this game. Ooh, are you okay?
Yeah.
In this game, I forgot to change the respawn point. So, uh,
Oh.
in this version, the player always respawns down here. So, maybe I will have to go over moving your respawn points. And in fact, I can do that real quick, just for funsies.
Mhm.
So, in the most recent version of the 2D, the top down player script, I have a little. That's not open. So, oh, is it still open over here? It might be. Find a respawn point. So I've got this, and I'll put it in here for. I have to put it inside of the script, which means it needs to be within there. So, what this does is it's public, it's void, it's public, so that way other functions can call it, because when I didn't have it public, things were bad. And it passes in a string called edge. And what it's going to do is it has two game objects. One of them is going to store the current place that you have labeled as a respawn point. And the other one is going to store the edge detector that has a respawn point attached to it as a child. So if I go back here, I've got the camera up here at the top, and it's got these edge detectors as children. If you remember, because they're children, they move around when I move the camera. So if I move the camera to the next room, it takes the edge detectors with it. So if I want to have the respawn point move with the camera, I'll put it on the edge detectors. And the reason why I'm putting it on the edge detectors and not on camera itself is because I feel like it. And also because the idea of like, oh, you have to re-enter the room, so it's goes back to when you entered that room again. You could make it so that way it actually resets everything when you respawn into a room, and it actually feels like you re-entered the room. But again, that's advanced stuff, and I'm not doing that. So I right click and I hit create empty, and you'll notice that it says 000. That one was on down, so I'm going to move it 1.5 up. Can you show me the difference? No. Love that.
I
All
had
right.
the same problem. You have to make them like very ludicrously high values because it doesn't move that much. Like mine, I have at 75. So
That's weird.
yeah, I don't know why.
Oh, it's because the scale on this thing is stupid.
That might be. Oh, that makes sense.
So if I
But
make
this
the
scale
scale on
needs
this
to be
100,
low.
then that'll work. Right?
Oh,
At least it should.
yeah.
Theoretically, it
I,
would. Because if this is 100th of that, and if I
well, wait,
multiply
wouldn't it
it,
still be moving it just in relation to the? I don't think the scale of the actual child matters in that. I think it's just the scale of the parent that matters.
it might be. But that is the thing, is that scales matter. Now I'm wondering
That
why
makes a lot of
1.5 worked
sense.
on my other thing.
Hmm.
Regardless, you move the respawn point away from where the actual edge is, because if I go and hit, like if I go respawn, I don't want to immediately hit my camera and then jump. Kind of defeats the point of respawning back in the room that I was in, if it immediately moves me away. So I move this, and I'm going to name it respawn. And I'm going to do that again a couple times, and make these different children. And they are untagged currently. This one's going to be negative 150 or negative 75 or whatever. That way it's their left edge is going to go. And this just goes through. This is going to be 5. So now I've got these respawn points, and they are children of the edges. So if I go to down edge, and I use the find function, remember find goes through and it finds all the children, and I use find looking for respawn, it's going to go find the respawn point that has down. So, cool. So edge, left edge. So it passes in, go find the object that is tagged left edge. Go find its child, and that's the new respawn point. So that's what the second game object is here, and that's what this function does. That way, it'll move your respawn point when you move into a new room. So it needs to be where you're moving the camera. Yeah. So it does that. This is the set of calls that it makes when I'm moving the camera. So I'll just copy this, right edge, left edge. I'll move that here. Sorry, I'm going a little bit over, but if
Yeah,
it
good
lets
work.
if it lets the game,
Work.
yeah.
Yeah.
All right, so then we're going to hit save so it recompiles. And now that should function. Crossing fingers. I move in here.
Oh, okay. I know what happened here. There's nothing tagged as respawn right now, so I just created
Oh,
another respawn object
that's right. I do
outside
have
of.
a default respawn, and it is currently tagged as respawn.
That is strange. Never mind.
All right,
I
so
had
something in the player
started
script is
to.
mad. All right, it's on line 186. So what's on line 186? This
Oh,
thing.
could it be? It's not named respawn point. Maybe it's named respawn.
Yep, you're right.
Wow, look at that.
I named them respawn point uh in the original time when I wrote it. So, one
Oh,
thing to keep track of is if you're reusing scripts from another thing, name them consistently.
maybe change the respawn point name on your right edge too.
Oh, no, I just changed what it's looking for.
No, but the right edge is still called game object.
Is it?
Yeah,
It's okay.
yeah, it's fine.
But you are right that that's something that I need to do. Huh.
Was
That's wrong. I respawned on the wrong side of the
interesting.
room.
Oh, interesting.
Why did that happen?
Maybe the door pushed you into the collider the edge that brought you
That
to the
might be
next room.
it. It might be. Yeah, so that might be why I was using 150 instead of 75. Um, Thank you for helping me decipher the code that I already wrote. You'd think I'd be able to decipher my own code.
It's a miracle if anyone's able to decipher their own code.
Yeah, it's almost like I should write comments or something.
Comments are unnecessary, right?
Comments are kind of necessary when you're providing your code as a tutorial for other people.
This
Yeah.
is fair.
Alright, so let's try that again, shall we? We die, and now we respawn back in the room. We're trapped in here. We need a way out. We need a way to kill the enemies. Stay tuned for next week.
Whoa, cliffhanger, that's so cool.
Yeah, I've been trying to give cliffhangers every week. I don't know if that's been working. This is perhaps the first time where it's really dramatic because we're actually like locked in a room and there's many enemies and ooh.
This is the suspenseful two-part episode.
No, it's an entire series. But yeah, thank you for tuning in, and I'll see you next
Yeah, yeah.
week. Or for those people who are watching the VOD, I'll see you in the next episode. Um, where we're actually gonna kill things. Yay, murder!
Yay.